minus 90th position. The correct order of the basic strength of methyl substituted amines in aqueous solution is. Here they are asking that among the given 4 options, which one is the highest basic strength in aqueous solutions? We know that basic nature means the donating ability of an nitrogen. Here lone pairs donating ability. We know that in aqueous solution, 3 factors are affecting the donating nature of amines. The first one is electron donating, that is plus sign, inductive effect. The second one is solvation effect, that is a hydrogen bonding. The third one is steric hindrance. Firstly, draw the structures of primary, secondary, tertiary amines. Here, CH3 bond NH2 containing 2 lone pair of electrons. This is primary amine. Secondary amine structure is CH3 bond nitrogen bond hydrogen bond CH3. Here presence of 2 lone pair of electrons. This is called secondary amines. The tertiary amine structure is CH3 bond N, 2 lone pair of electrons, bond CH3 bond CH3. This is called tertiary amines. When you observe the structures of primary, secondary, tertiary amines, we clearly conclude that tertiary amines having the steric hindrance. That's why the lone pair donating ability decreases. By know this point, you can easily eliminate option 2 and option 3. Due to the presence of steric hindrance, the tertiary amines donating of lone pair of electrons decreases. But in primary amines, after donating its lone pairs to others, the positive charge is neutralized by solvation effect, that is hydrogen bonding. So the donating ability of primary is greater than tertiary. When you compare the primary and the secondary is higher donating ability. Why? Because of higher solvation effect. So we conclude that its order is secondary greater than primary greater than tertiary. Now let us verify the given options. Here primary greater than secondary greater than tertiary. Option 4 is also eliminated. Here you have left with option 1. It has secondary greater than primary greater than tertiary. Secondary, primary and tertiary. So option 1 is our correct answer.